So far, we talked about the fluid at rest. It means that we talk about the property of fluid that is not move, where we may call it the static property. Okay. Now, we will talk about the fluid that move, and when the fluid move, it has many properties that different from the fluid at rest, and the subject that study about the moving fluid is a fluid dynamic. This is the fluid dynamic. Fluid dynamic is one of the most complex subject in physics and in engineering, and even nowadays we still don't completely understand the dynamic of fluid. Anyway, in this class we will talk about some ideal fluid, some simple fluid that we can handle, or we can solve the problem about those simple fluid. Okay. The motion of the simple fluid may look like this figure. Okay. If you look at this figure, this is in the wind tunnel. Then they test the aerodynamic of a car, and they flow the air that hit the car, and look at the pattern of the flow of the air when they pass the car, and they may maybe the vapor, or maybe some kind of dust, they let it flow together with the air to see the part of the motion or part of the flow of the air. And this kind of motion is a motion of we call it laminar flow. We will talk about it in more detail later, but this is an example of the simple fluid. You can see that the line of flow is quite have some order. Okay, we can define clearly the line of flow, and we can track the motion of the fluid by tracking the line of flow of the fluid. If we compare with the second figure, this is the motion of the smoke of the cigarette. Okay, the cigarette is not good, certainly, but we look at the motion of the smoke. Maybe it's not necessarily come from the cigarette, and it's smoke. We can see the complexity of the flow. We cannot define the line of flow, unlike in this case, but the flow has a chaotic behavior, and we call this a turbulent flow. Okay. We will not talk about the turbulent flow in further detail here, because that is an extreme complicated subject. So we will talk about the simple fluid like this only. Okay. When we talk about the simple fluid or ideal fluid, there are some property of the ideal fluid. First, the fluid is non-viscous. It means that we don't have the viscosity in the fluid, or this is equivalent when we talk about the frictionless surface. Okay, so we don't have to worry about the viscosity of the fluid. The flow is steady. The flow is steady. The meaning of the steady flow is that the velocity of the fluid at a point is a constant. Okay, if we look back to this example again, okay, if I measure the velocity of the liquid here, maybe at this point, okay, change the color. Okay, if I measure the velocity of the fluid at this point, the velocity of the fluid at this point will not change in time, or it is a constant in time, but you may have the different velocity if you change the position. Like you may have this as a v1, and if you move to this point you may have v2. Okay, but v1 and v2 will not change in time, so we call that the steady flow. That is a steady flow. Third, the fluid is incompressible. It means that you cannot change the volume of the fluid. You may change the shape of the fluid, but you cannot change the volume of the fluid, so we call it incompressible. And last, the fourth condition is that the flow is irrotational. The flow is irrotational. It means that you don't have any rotation in the fluid, or the fluid not rotate. Okay, so it means that if the fluid flow like this, it will have a path of flow, but you don't have this kind of flow. You don't have this kind of flow that is rotated, something like this. And when we say that the flow is irrotational, it means that there is no flow pattern, this flow pattern, so it's irrotational. So we have to consider only the translational motion of the fluid only. We don't have to worry about the rotation of the fluid. When we look at the simple fluid, we can define what we call it the streamline. It means that if you look at the flow of fluid, you can define the line of flow very clearly. This is very similar to this example. Okay, if you flow the air in the air tunnel, wind tunnel, not air tunnel, and you can see the line of flow very clearly, right? So this is we call it the streamline. Okay. In this figure, each line represents the line of flow of the fluid. Okay, the line of flow of the fluid, and at each point along its path, it means that each point along the line of flow of the fluid, the particle velocity is tangent to the streamline. Okay, so it means that if you want to measure the velocity, the direction will be tangent to the streamline, which is simple. We can understand this quite easily, because this is similar to the motion of the of an object. If you draw the line or the trajectory, the velocity will be tangent to the trajectory of the object. Okay, and if you group the streamline like this as a bunch of the streamline, we call this tube or the bunch of this streamline as a tube of flow. Tube of flow. Even though the fluid is not flow in the tube, its behavior is very similar to the flow in the tube, because we can define clearly define the streamline and the bunch of the streamline. We call it the tube of flow. Okay.